We are really excited to be presenting to you today Wi-Fi Day, how we can help save the world from bad Wi-Fi. So we have got myself and Mac.
Hi guys, I'm sure that some of you might have heard about us. Matt and Mac are both directors of Ekahau University, ECSC, and product marketing. We are extremely honored to be here. Thank you very much, all of you, for joining. Without you, there would be no us. So honestly, guys, you are amazing. Let's start.
Exactly. So before we kick off today, we wanted to share with you some survey results. So we know that, Wi-Fi is mission critical and it continues to increase in importance, but we posed this question to a survey, and it is: over the past 2 years, how much more or less important has Wi-Fi become to your business? And then 57% said it's much more important, and 38% said it's somewhat more important. So that's 95% that say Wi-Fi has become more important to their business in the past couple of years.
And another result from our survey that we have run several months ago is: how many of you believe that your company's Wi-Fi works really, really well? And it's a little bit on the funny side because 50% of us, we don't think that Wi-Fi is performing at its best. So I guess there is a little bit of a room for improvement.
Yeah, only 50% think that Wi-Fi is truly working well. How can we help you get that 50% closer to 100%? And well, that's why we've come up with our 3 steps to great Wi-Fi. So first of all, step 1, a great network, it starts with a great design. So what we need to do here is making sure that we gather requirements from our customers or stakeholders who's asking us to do the design. We go on site, we gather that data that we need to then go back to our beautiful AI Pro and start creating our predictive models. Then once we have created our predictive models and the design has been installed, that's when we move on to step 2. And with step 2, what we're going to do now is validate with our super accurate Sidekick 2. So we're going to validate to make sure the APs have been installed correctly, the coverage is what we've expected, we're not seeing too much co-channel contention, all of this amazing details that we can capture with our Sidekick 2. Then we can move on to step 3. How do we keep these Wi-Fi networks staying high performing? And that is by doing regular health check surveys. They are so important. How do we account for any changes in the environment if we're not regularly checking what's going on by doing health check surveys? What can we capture here? Things like noisy neighbors. Maybe we have some new neighbors moving in upstairs, downstairs, below us and creating lots of channel contention. Perhaps someone from the team has brought in a device that they thought was innocent and not going to cause us any issues on the Wi-Fi, but actually it turns out to be interfering with the Wi-Fi. What if the office has been reconfigured? Maybe some walls have been taken down, moved. We've got higher density areas for some public events. We need to account for that now with maybe some additional access points for the capacity. How about in your warehouse, if the stock is changing in those racks, or you need to shuffle those racks around to account for some different size stock that comes in? We need to do these health check surveys to keep the Wi-Fi high performing.
Totally. And to satisfy the 50% of us that believe that Wi-Fi is not working and to learn how to make it working properly, we have attendees from all over the world, guys. We appreciate you joining from 102 different countries across 17 different time zones. I'm not sure how many time zones there are in the world, probably more than that. Stu probably would be able to answer that question. But it's a truly massive global event that we're on here today. Again, guys, we are super happy to see you all here, and let's learn how to get rid of bad Wi-Fi.
Yeah, and one other thing we wanted to share with you is actually in 2022, our users have surveyed some crazy amount of distance. So 76,000 kilometers, or if you like to work in miles, that's nearly 47,500 miles, which is basically equivalent to nearly twice the circumference of the Earth. I hope you have been wearing comfortable shoes or trainers when you've been doing those surveys, because that is some serious distance. And then not only that as well, we have had over 3 1.6 million simulated APs to your designs. That is a lot of access points.
So guys, our presentation will have a little bit more of a practical spin on 6 gigahertz. We are going to be talking about tips and tricks of design for 6 gigs, where we will share everything that we have learned about 6 gigs and 6 gigs designs. We will try to keep it as deep as possible, depending on time. We have 30 minutes for our presentation, so it will be sometimes a little bit high level, and sometimes we will dive a little bit deeper. We also have a few demos for you, and hopefully you will see how great it is to design for 6 gigs today.
First of all, tip number 1 is ensuring that we get your predictive model right. So what we mean by that is that the most crucial part for doing your predictive model is making sure it's accurate. And one of the things that we really need to ensure is accurate is the wall attenuation values we use for the materials that we're using in our predictive design. And how do we validate that these are correct? Well, we have an amazing new feature in our Ekahau AI Pro called the wall calibration tool. And just from using your Sidekick, doing a survey, making sure we capture enough data, we can automatically detect what those wall attenuation values need to be across all 3 frequency bands. So I know Mac has got an amazing demo of this prepared. So why don't I get that?
I cannot wait to take a look at it, Matt. Thank you very much. So guys, just to reiterate, this is one of the most amazing features that we have introduced recently. We are using it all the time while working on real projects, real designs. And I cannot imagine like going to the site and measuring wall attenuation manually anymore. And also with the Sidekick 2, you measure across all the bands at the same time, and attenuation can be different across all 3 bands. And this is something that you might not expect, you might not see. So we can't see through the wall. Sometimes we knock on the wall and the wall appears to be a drywall, but there is something inside, maybe a concrete, maybe a brickwork. If we don't measure it, we won't know. So let's take a look at the real demo of the wall attenuation calibration tool in Ekahau AI Pro.
Let's do it. So I'm going to get that ready, prepared for you now, Mac. And
Wall calibration tool in Ekahau AI Pro is such an amazing new feature. I truly want to cry from happiness each time I'm using it. It allows us to use validation survey data to calculate real attenuation values of all the walls, and therefore creating spotlessly accurate building model for us to use in a predictive design. All we need to do is to walk with our Sidekick on both sides of all the walls we want to calibrate the attenuation of. Preferably use a Sidekick 2, as it's mega fast and it measures attenuation across all 3 bands. We initially use walls profiles built into Ekahau AI Pro. You can draw the walls before or after the survey. It doesn't really matter. We then fire up the wall calibration tool to see Ekahau's suggestions for each wall type used in the project. If we have enough data points captured on both sides of the wall in question, we then see the quality of the attenuation prediction marked as good in green. Sometimes our wall's attenuation assumptions are wildly different to the real measured wall attenuation. For example, we thought that this thin concrete wall has 5 dBs of attenuation, where in fact it has 14.5 dBs. This might translate to an increase in the number of the APs that we need to cover this space with. We can apply the suggestion one by one or apply all of them at once. Notice that calibrated walls were added to the AI Pro and are now used in the project. You can now remove your survey routes to clear up the project file and enjoy the calibrated, accurate building model that you can now use for your predictive design. Take the guesswork out and get your design right first time.
Yeah, I mean, Mac, you said it, but I think this is one of my favorite new features of AI Pro. Being able to take out that guesswork and knowing what is behind those walls is kind of like magic to me. So the combination of the Sidekick plus AI Pro to find this out for you. And I remember back in the day when me and you, Mac, was going on site, knocking on walls, trying to figure out how much this was attenuating the walls and what is that behind there, and having to manually do it. It's such a time-consuming process.
It is indeed. I can't say I miss those times. And guys, if you use a Sidekick 2, it has 4 radios that we use for scanning. So all you need to have is a Wi-Fi coverage from anything. It can be a brownfield Wi-Fi, it can be AP on a stick, whatever you have, it's good enough to use to calibrate wireless attenuation automatically.
Yeah. Well, that was our first tip, Max. So why don't you tell everyone what is our second tip?
I will be delighted to do so. So first tip was to get your model right. Easy peasy, lemon squeezy. Now, tip number 2 says design for your real devices. Use device offset mind LCMI. What does it mean? It means that wherever you do a Wi-Fi design, you have to understand what device you are designing for. LCMI, it stands for least capable, most important device, and it will be different in different environments. In a warehouse environment, it can be a handheld scanner, for example. In enterprise carpeted office space, it can be a smartphone or a tablet. But we need to understand what is the sensitivity of those devices, what are the capabilities of those devices, what are the channels supported by those devices, what are the discovery methods to discover our Wi-Fi across all 3 bands for those devices. And the funny thing is that 6 gigahertz is up and running now, okay? It's available. You might even have it in your corporate environment. But tons of devices today, they will use 5 gigahertz antennas to receive on 6 gigahertz. So you really need to understand what is the difference between your free space path loss calculation in your predictive design versus the real client sensitivity based on its capabilities, radios, and antennas design. And you might be shocked by looking at the RSSI on 5 gig and 6 gig, where the difference will be massive, or at least quite big. And if you want to have tri-band Wi-Fi, and if you want to have a solid 6 gigahertz coverage, that might mean that you might require more access points to cater for those clients today.
Yeah, I mean, I found that really interesting when where people will talk about client devices and testing them and stuff about quite a lot of the 6 gigahertz client devices out there on the market are using 5 gigahertz antennas. So that does play a big impact. And the good news here is that you can configure these device offsets. So once you do your testing, you can configure that in AI Pro to make sure that you have got everything accurate just how you would like it to be. So why don't we move on to our tip number 3 then? And that is always design and then never assume. So what are we talking about here? We're talking about, again, another amazing new feature in AI Pro, which is called the Network Simulator tool. I'm flashing back to our days again of doing professional services, Mac, and a lot of our customers, when we were talking to them, when they were at the point of their Wi-Fi lifecycle upgrade, they would just want to rip down their current access points and their current locations and then install the latest and greatest version of the access point model that is currently out, because it can be quite expensive to have a new design done or run some new cables and rip this all out. And they think that, you know, if I just take down my access points in their current locations and put up these brand new access points, it's going to fix all of my Wi-Fi issues. And for us to try and explain that to customers was quite challenging, to say, hey, you know, how you wanted the Wi-Fi to work a few years ago is completely different to your expectations for how the Wi-Fi is you want it to work today. So you really would benefit from having a new Wi-Fi design done and making sure you get it right first time, get the right number of access points. You don't have to go through all of that pain of buying a certain amount of access points, physically ripping them out and physically putting them back in, and then you and the users being disappointed that the Wi-Fi was not working how you would like it to be. So we actually have this amazing new feature that can show you what it would look like to upgrade to a new model of access point and in the same location. So we are going to have another demo for you, which you have so kindly prepared, Mac, as well, which I will get ready.
Of course, thank you very much, Matt. So guys, just to reiterate what Matthew has said, you cannot rip and replace one-to-one scenario from old APs to new APs if you don't have a decent design. And sometimes, even if you do have a decent design, rip and replace will not work as expected. So instead of talking about it, as always, let's take a look.
Yeah, I'm really excited to show this to everybody. So here we go.
Network Simulator allows you to use validation survey data from current APs to simulate how an upgrade to new, shiny access points would look like without having to actually do that upgrade physically. Currently, signal strength is not the greatest in the world on both 2.4 and 5 GHz bands, and there is no 6 GHz at all. With current AP's model and placement, most of the floor is red in network health. You can check what's failing and where using Inspect tab. We often hear claims that replacing vendor X with vendor Y will fix all your Wi-Fi issues. But is it really the case? Let's see what happens when we change current Ruckus APs to brand new, shiny Aruba 6 GHz enabled access points. Are our coverage issues fixed? Network health has not improved at all. In fact, it has dropped across both 2.4 and 5 GHz bands. An addition of 6 GHz in brand new APs might have added some capacity, but it didn't really fix our primary and secondary coverage issues. You can compare the one-to-one APs rip and replace simulation by switching between generated network view to see predicted performance of new APs and all my networks to see the performance of your existing network. As you can see, simply putting new 6 GHz APs didn't solve our issues. You can't fix bad design with newer hardware. Spotless Wi-Fi design is the key to amazing Wi-Fi.
And Mac, I could not agree any more with you right there with that statement.
Thank you very much. Nothing unusual, Matthew.
I wanted to say for a first time I agree with something you said, but no. Great.
We always agree. Okay, so that was the network simulator, and that was tip 3. Okay, and let's move to tip 4. So tip 4 says save time, use AI. And to do that, we can use Ekahau AI AutoPlanner to save as time. No matter what frequency band you are designing for, you can use AI AutoPlanner. So AI AutoPlanners, guys, it uses the requirements that you specify while working on a project, working on a predictive design. And then based on those requirements, based on the walls attenuation that hopefully you have calculated using a wall attenuation calculation tool, you have an amazing model, you have your coverage areas done right, you have your capacity requirements specified in a way where they are not exaggerated, where they are not underscoped, they are as close to being right as possible. Of course, it's not possible to do it 100% right, because we cannot predict what people are going to be doing all of the time, but we have to be reasonable, okay, while setting up the requirements. And then you run AI AutoPlanner to place access points for you on the map. And AI AutoPlanner, it can be used by both the Wi-Fi pros, and even if you are starting your career in Wi-Fi, you can use AI AutoPlanner. So for the Wi-Fi pros, you can save time by placing access points on the map for you, sometimes few hundred of access points across multiple floors. And most likely, the placement of the access points will be spot on after running it. If not, you can always move some APs around so it satisfies your needs and OCD. And if you're if you're just starting your career path in Wi-Fi, you can use AI AutoPlanner to give you confidence to know where to start with Wi-Fi design and to start producing high quality designs, even if you don't have too much experience yet. So it's super easy to start using, doesn't matter how much experience you have. But instead of talking about it, let's take a look.
Let's see how we can help save you time, but also get your Wi-Fi designs right first time with Ekahau AI AutoPlanner. What we have got here is a predictive model with 3 floors inside of this predictive model. So to run the Ekahau AI AutoPlanner, I'm simply going to click on this blue icon, which will open up our AI AutoPlanner window. And then the first thing that we need to do is select which model access point we would like to use for our design. And we have got thousands and thousands of access points, and I'm going to select this Cisco 9136i access point for this design. Once we are happy with the AP that we have got selected, we can then expand our advanced options. Inside of our advanced options, we have lots that we can configure here, from the transmitting power we would like to use on all 3 different radios to the antenna heights. And what you might notice here is that across the 3 floors, we have got areas configured with devices too. So we can ask the AI AutoPlanner, when it's doing its design, to also take into consideration the capacity requirements of your devices and their SLAs inside of the areas that we've got configured across multiple floors, simply by hitting this optimize with capacity toggle to be on. Once we are happy with that, the next thing that we can configure is the channels that we would like to use inside of our plan as well. We can select the 2.4, 5 and 6 gigahertz channels which we would like to include in our plan, as well as which bandwidth or channel width that we would like to use on the different frequency bands as well. So once we're happy with this, we can then simply hit the create button and our AI Auto Planner is going to start preparing to deploy our Wi-Fi network for us, and we can see the dancing APs moving around, and then whoa, oh my goodness, look at all of those iterations that the Auto Planner is crunching through right now, going over multiple different positions for the access points and the configurations. Then once the Auto Planner has deployed the network for us, we can see now that we have got 49 access points placed across the 3 different floors, and we can then check the details of our network health summary. So how is the Wi-Fi performing across all of those 3 floors? Are we meeting our requirements? And we can see all of those beautiful green ticks, which means we are meeting our Wi-Fi requirements across all 3 frequency bands across all 3 floors, which is pretty cool because this was only a matter of moments before this was deployed for us. Then if we would like to dive into a bit more detail, we can select the inspect tab and we can select some locations across the floor plan, and we can see our passing requirements, and we can check out what is happening in the different specific locations across our floor plans to make sure we are happy with how the Wi-Fi has been deployed. So it is as simple as that. We can create a high performing Wi-Fi network for you at a simple click of a few buttons.
How amazing is that?
Yeah, I mean, I personally love using AI Auto Planner to be able to save some time when, designing across multiple floors, and it really is a click of a few buttons. And Mac, I know you love those.
Everyone likes different things, because I will be playing the AI Auto Planner demo at my Christmas table to show the family the dancing APs in green and red, so they look like a Christmas tree. So guys, that was AI Auto Planner. Let's move on to the next tip. And the next tip number 5, is to cover what you want. And I really am super excited about this tip, because you actually can use directionals with 6 gigahertz now, or almost you can use them with 6 gigahertz now. So 6 gigahertz, when it was introduced and first access point, when they hit the market, we only had omnidirectional internal built-in antennas to play around with the LPI device class. LPI, it stands for low power indoor, and this is the first class available to us in 6 gigahertz. Without diving too deep into what LPI is, let's just remember that LPI, low power indoor, allows us to use fairly low power. It can be used only inside, and it doesn't require any external databases to tell us what channel to use, what transmitting power level to use. We can use it inside as we please. So it's very similar to what we know and love about 2.4 and 5. Since we are discussing the classes, before we jump into the directional antennas, let's talk about standard power as well. That's a second device class available to us almost. So the difference between LPI and SP standard power is that you can use standard power both inside and outside, and you can use higher power, okay, on your radios. But also it has one additional requirement called the AFC. AFC stands for Automatic Frequency Coordination, and it's a database that tells your radios what channels and transmitting power levels they are allowed to use in their location. This is to protect existing 6 gigahertz tech from harm from Wi-Fi, okay? And your SPAPs, they need to be able to locate themselves in order for AFC to tell them what channel and transmitting power to use. Now, what do we have available? LPI APs with built-in internal directional antennas will be available soon, okay? And SPAPs, they are available today, okay, from some vendors. you can buy an SPAP with internal built-in directional antenna, but the catch is the AFC that tells the access point what channels to use is not live yet. It will be live in Q1 2023, and when that happens, the radios in your fancy new 6 gigs APs with directional antennas, then they will be enabled. For now, they will stay disabled, but it doesn't stop you from buying those APs today and from using Ekahau AI Pro to design with these directional antennas built into 6 gigs APs today. So let's do it. Now, why would you like to use directional antennas to begin with? And there are two main reasons, actually, in my head. There are two reasons. There are probably more. First reason is, if you use a mix of omnis and directionals, you can use the differences in environment, different attenuating materials, different layout of the building to cover what you want, and therefore to decrease the CCI, cross-channel contention, cross-channel interference to minimum. And also by using directional antennas, you can place your access points and antennas in a way where you direct the signal towards your clients so they can hear you better and you can hear them back better as well. This increases the SNR, and conversely, this increases the MCS rates your clients operate in, and it makes Wi-Fi experience not only lower when it comes to contention, but higher when it comes to real throughput. So everyone is happy. Again,
Yeah.
tip 5, cover what you want with a mix of omnis and directional antennas.
I think that's the golden rule, isn't it, Max? So cover what you want whilst not covering what you don't want. So it's a little bit easier said than done, but with Ekahau and AI Pro, you can make sure that you do get that right. So let's move on to our tip number 6. And tip number 6 really comes down to channel planning. So 6 gigahertz brings a ton of additional spectrum to the US. So that means that you guys are going to be able to have up to 59 20 megahertz wide channels, which is a huge amount of additional channels to use. And what we can see here is all of the channels highlighted for 6 gigahertz, but also we have highlighted some channels in white. And the reason why we have done that is because these are what are called the preferred scanning channels. And why is that important? Because we believe that the most likely default channel width for your channel plan in the US is going to be 80 megahertz wide channels. And the reason for this is because we are thinking about how Wi-Fi clients are going to be discovering 6 gigahertz radios to associate to. If you think of how we associate our client devices associate currently, is that they scan through the Wi-Fi channels available in 2.4 and 5 gigahertz. And now if you think about the additional 6 gigahertz frequency band that they've got to scan through, if they had to scan all of those channels to go and find an AP to associate to, it could take a really, really long time. And that would really impact any time sensitive applications these client devices were doing over Wi-Fi. For example, a video call or a voice call, if you had to scan through all of those channels to find 6 gigahertz radio to associate to, that call is probably going to either have a poor connection or be completely lost entirely. So why is the PSC channels important? Because on 6 gigahertz, our Wi-Fi clients will only scan those channels. So that means instead of having 59 channels to scan through, they will just scan those 15 PSC channels. So that's why it's really important when you're doing your channel plan, especially if you're in the US where you've got that huge amount of spectrum to use for 6 gigahertz. You think about your channel widths and your channel plan and make sure your access points are using those PSC channels for the connection for the clients. You look like you wanted to
For
chip
the
in there.
clients, discover them. Yes. So in the States, it's a different game because we have 1.2 gigs of available spectrum in new 6 gigahertz band. Just to put it into perspective, we have around, well, we are using around 60 megahertz on 2.4 and around 500 megahertz on 5 gigs. So 1.2 gig, 1,200 megahertz of additional spectrum is, my friends, a massive, massive deal. So let's move to a next region. Okay, so tip 6.5. It's not tip 7 yet. Have a solid channel plan outside of the US. So Matt has told us that it's super great to use PSC And yes, it is great when you have 15, 80 megahertz wide channels that you can use your PSC with. Okay, so 15, 80 megahertz channels, it's a massive deal because you can have low contention in your network and your MCS rates, your throughput, your data rates, they will be insanely high. So that's a way to go. PSC is an in-band scanning method that is very similar to how we discover our access points, our radios today. We are using in-band scanning methods. So if I'm a client and if I want to find an access point on 5 gigahertz band, I will go to 5 gigahertz band and I will ask someone out there on channel 36, then I will have a response to my probe request. Yes, I'm here, I can do that and that. If you do that across 59 channels, that's a problem. If you do it across 15 channels, it's not such a massive problem, is it? But you can only use PSC really on 80 megahertz channels. And it's not a problem when you have 1.2 gig of spectrum. In Europe, we don't have 1.2 gig. We have additional 500 megahertz of spectrum. And that translates to, what, 6 available 80 megahertz channels? And with 6 80 megahertz channels, when we want to use PSC, can we use it? Of course we can, but can we use it in higher density where we will have tons of radios collocated in the same geographical area? No, then it becomes quite challenging. So we will have to rely on different discovery methods. We will have to use 20 or 40 megahertz channels in order to make sure that our CCI is not extremely excessive. We don't want to have too many radios and too many clients operating on the same channel, because with Wi-Fi, typically only one client talks at the same time, and that includes the access point. So with 20 or 40 megahertz channels and no PSC, we have to rely on different discovery methods. And the biggest discovery method, we think, will be RNR. And RNR, it's an out-of-band discovery method, and it allows your client to, let's say, scan 11 2.4 gigahertz channels. And if the access point that is tri-band, it has collocated 6 gigahertz radio, it will respond to the client that is asking about 2.4. By the way, Mr. Client, I don't only have 2.4, I also have 5 and 6 gigahertz radios, and these are the SSIDs enabled for you, which is absolutely mind-blowing, because you don't have to be scanning 80-something channels, all of them. You can just scan 2.4 band or 5 gigahertz band. That, together with 802.11k neighbor list, can massively speed up discovery of your 6 gigahertz networks. So that's US versus EU.
Yep. And we have some bonus tips for you. So we're not going to dive deep on what these are. So what we suggest is that you screenshot it, keep it for later. And when you get the recording, you can come back and scroll through and find this here. So these are some additional tips we wanted to give to everyone today to take away from our tips for designing for 6 gigahertz.